tides. We want to write a trig function for the tides. In this case, they tell us, and I'll let you read this yourself, but we've got consecutive high tides, approximately 12 and a half hours. As you go through and read it, it gives a whole lot of information, but the high tide occurs at 8.1833 hours, and low tide occurs at 14.2333 hours. The high tide is 13.2 feet at high tide, and low tide was 2.2 feet. They want us to sketch a graph. Now remember, we need some things to write this equation. We need an amplitude, period, a B, an H, and a K. Now it's not a bad idea to go ahead and sketch this thing. So we got to think through, how do you want to sketch something like this? So if the period's 12 hours, but the high tide and low tide occur at not 0 and 12, we've got to be smart about how we're graphing this thing. So let's go ahead and mark this thing something like this: 2, 4, 6, 8, 10, 12, 14, 16. Okay, we have a high tide at 13 feet, so let's go 15, 10, and 5, just so we have a visual of it. So high tide occurs at 8.1 hours at 13 feet. So right here is going to be right about there. That's my high tide. That ordered pair is 8.1833, comma 13.2. Low tide occurs at 1400 hours, so 14.2, and that's a height of 2.2 feet, so that's going to be right about there. And this ordered pair is 14.2333, comma 2.2 feet. Okay, this curve does this. Comes down, curves into that. We know that this thing continues like so. Something like that in terms of what we're looking at. Okay, now remember, we needed the high and the low. So we're going to calculate with these points. I'm going to write it as a cosine function. The h value is going to be 8.1833, because we got to shift over that far to start the cosine function. Let's go through the process. Maximum, max y minus min y divided by 2 equals, and let's pull out the calculator at this point. Okay, so we got 5.5 for our amplitude, and now we got to do the same thing for the k value. Remember, that's maximum y plus minimum y divided by 2. All right, and that one's going to equal 7.7. I'll let you do the arithmetic on that one. Period we know is 12.5, so the b value is going to be 2 pi divided by 12.5. We don't like decimals in fractions, so I'm going to multiply both numerator and denominator by 2, and I will get 4 pi over 25, which can't be reduced. I just leave it like that. I now have all the information I need to write this as a cosine function. Y equals 5.5 cosine 4 pi over 25 x minus 8.1833 plus the k value 7.7. You could write it as a negative also if you wanted to. But what about as a sine function? is this one is this even reasonable? We know our equilibrium should be at 7.7, somewhere in there, which gives us these points. Uh, what is the halfway value between those two? Which might help us find the halfway value over here. Um, so just again, pull up the calculator. But the halfway between 8 and 14, so it's going to be 14.2333 minus 8.1833 divided by 2 gives me a distance of 3.025, which needs to be added to the 8.183, so plus 8.1833 or 11.2083 for a sine function. Okay, so everything else is going to be the same. Now, how accurate is this? This could be an estimation. So y equals, and this is going to be a negative, right? So this is with the reflection here, because I'm starting at that point going down, means that this has got to be negative 5.5 sine 4 pi over 25 x minus 11.2083 plus 7.7. Now again, we'll find out that the calculator can do a more accurate job of this, but not bad for sine and cosine. Could it be positive? Yeah, you have to find that point, and that's possible too.